Good morning. So in this lecture video, I'm going to explain some more questions appeared in the university exam. So let's see a simple question appeared in the exam. That means if the internal memory 20H contains AA, I mean the memory address AA, sorry, 20H contains AA and 07H, I mean memory address 07H contains 55H. What is the content of register A and status of carry bit after executing the following code? So this is the simple code is given. Move C, 07H, move A, 20H, add with C, add C, A, 07H. So we need to analyze the program. So let's see. So this is the program given and write the memory content. So this is the address and this is the content as per the question. Memory address 20H contains some is AA. So 20H is contains AA and 07 contains 55. So 07 contains 55. So observe the first instruction, move C, C, 07H. So 07H is the bit address. Since the destination is a carry flag, it's the bit address. So we need to check the bit address 07 contains what value. So as you know, bit addressable memory is from 20H. Okay, so this is the bit address of bit 7 of 20H. That means 20H can be written as a bit view. So this is the 20H location. These are the bits. These are the bits 0. I mean AA means 10101010, and these are the bit addresses 000102 like that. So 07 is the bit address of bit 7 of 20H, and it contains 1. It contains 1. So 1 will be copied to carry flag. After executing this instruction, carry flag becomes 1. Correct? Next, move A, 20H. So now it becomes the 20H is a byte address. 20H contains AA. So A will be equal to AA. And see, add C, A, 07H along with the carry flag. So A is equal to AH plus 07 contains 55. So don't get confused. So this 07 is the bit address. That is address of bit 7 of 20H. That is 1 that is copied to carry flag. And this 07 is an byte address because destination is a byte value. So that 07 contains 55. So this instruction performs operation of content of A, that is AA, plus content of the location 07, that is 55, plus carry flag is already set to 1. Okay, so the result is 00 and carry flag is set to 1. Okay, so here one confusions, this 07 is a bit address and this 07 is the byte address. If you say byte address, it contains 55, and if you say bit address, it contains 1. Clear na? A simple program appeared in the exam, but you need to analyze carefully. Next, we'll see one more question appeared in the exam. Write an assembly language program in 8051 to add two 16-bit numbers. Two 16-bit numbers stored in external memory. After addition, store the result in internal data memory. So the program is to perform the addition of two 16-bit numbers. Those 16-bit numbers are stored in external memory. They not specify the external memory address. You can take anything. And after the addition, they are expecting to store the result in internal data memory. Let's consider one example. 16-bit numbers. So 88 A5 plus 7B 85. So you are expecting the result 1042A. So we consider most significant digit, that is 1. We consider this is a 0. We append the 0, it becomes 3-byte result. Okay. Let's see. So we'll do manually how we can perform. So we start with the low digit. 5 plus 5 means 10. 10 means in hexadecimal is A. And next is A 10 plus 8, 18. 18 means 1 2, 2 1 carry. So carry plus 8, 9, 9 plus 11, 11 20. 20 means 1 4. So 4 1 carry. Again 9 plus 7, 16. 16 means 0 1 0, 0 1 carry. So that will be considered as a more significant digit the result. So to make it as a byte, we append a 0. So it becomes 3 byte result. 3 byte result. Clear now? So how microcontroller performs this operation? It divides the operation into two. One is low byte operation and another one is high byte operation. So for low byte means it performs A5 plus A5. So it is equal to 2A, and carry, there will be carry, and that carry is supposed to be added into I byte. So here it becomes the result 04 and along with the carry, and carry will be considered as I byte result. Correct? And now to perform the low byte operation, add instruction is sufficient. But to perform the I byte operation, we must use add C to consider the carry from the previous byte operation. Okay, this is what multi-byte addition. Clear now? Now we'll see the program. First we'll see let the numbers are stored in the external memory now at the address 5000H. So at the address 5000, low byte of first number, that is A5, and 5001 I byte of first number, that is 88. And then at the address 5002, low byte of second number, that is 85, and at the address 5003, I byte of second number, that is 7B. Okay, so and we are expecting the result, 3 byte result. We'll store the result in internal memory. Let's say the address 20 21 22. So low byte 2A 04 and then 01. So with this memory we will write a program. Okay, simple. See, start with the 00H. So yeah, since it is an external memory, no, its address supposed to be in DPTR. So make move DPTR comma hash 5000H. So DPTR becomes 5000. That means it is pointing to the location 5000. And get the number. Get the number. To get the number, move X A comma at DPTR. So A is equal to low byte of first number, and then store that into temporary result, because we should make A free. A free. So because we need to access low byte of second number, again that should happen through A register only. So temporarily stored in R0. Okay, and now A is free. So make DPTR with the address 5002. That means address of low byte of second number. Get the number using an instruction move X A comma at DPTR. So now A is having low byte of second number, and low byte of first number is stored in R0. Now say add A comma R0, A comma R. So it performs low byte addition. Correct? And this low byte should be stored at the location 20H. So say move 20H comma A. So low byte operation is over. Next we need to do I byte operation. For I byte operation, again I byte of first number is at 5001. So yeah, so once the low byte operation is over, we should make DPTR to point I byte. So first we copy DPTR with the 5001H, that is address of I byte of first number. Okay, get that number into accumulator and store that into R0, and then use the same instructions with DPTR is equal to 5003H, that is address of I byte of second number, and get that number into accumulator and add with carry. So here we are using add with carry A comma R0, and store that result into 21H. 21H. Clear now? So this is the second byte operation. So what is the third byte? Third byte is 01 if carry occurs. Otherwise it is 00. So that is why we use jump on carry store 01. So check carry after this addition. If it is carry is set, go to store 1 and store the result 01. Otherwise no carry means I byte result is 0 0. So move 22h comma hash 0 0h and go to last S jump, I mean control low. And then if it is carry, it will come to store 01h. Here it stores move 22h comma 01h, correct? And then control low. This is the program. So observe the instructions which are used to perform low byte addition and high byte addition. Same set of instruction. Only the changes is addresses are changes. And for the first operation we use add instruction, and the second operation we use RC instructions. So like this we can add n number of bytes, but program length is increases. Suppose if you say to add 3 byte numbers, so let's say the numbers are, first 3 bytes are stored at the address 5000, 5001, 5002, and second 3 bytes, I mean second number stored at the address 5003, 4, 5. So, and if you add a 3 byte number, result will be 4 byte. So store at the addresses 20 to 23. Let's see first we copy dptr with the 5000, get the first byte and store it in R0, and then copy dptr with the first byte of second number, that is 5003, get the number, add with the first byte of first number stored in R0 and store the result at 20. Then same set of instruction with the addresses 5001, 5004, and store the result at 21. So here the changes is RC. Okay. And then same for the third byte, same instruction, but addresses are 5002, 5005, and store the result at 22. Correct. So here also RC. And then last to check the carry. If it is carry is 1, store most significant byte of result is 01. If no, store most significant byte of result is 00. So like this, as the number of bytes are increases, program length is increases. So this is not an efficient way of writing the program. So in such a case, if the same set of instructions are repeating, okay, that we put it in a loop. So that I'm going to explain in next video. Thank you.